And welcome to Chapter 3. This is Learning Objective 2. We're going to break this up into two parts because we're going to be doing a whole bunch of math here. And so let me go ahead and share my screen with you. We can go ahead and get started. Okay, so again, in this chapter, what we're doing is taking some of the work that we've done in the previous lecture, in the previous chapter, and kind of propelling it into this one. So our learning objective here is we want to describe and calculate an absolute and comparative advantage. And we're going to be doing that really in part 2. But in part 1, I just wanted to revisit these problems and give you some practice as well. Okay, so let's go ahead and start the slideshow. Okay, so again, we're going to take a look at the difference between an absolute and a comparative advantage. And so for just our purposes, right now, we can say that an absolute advantage is who absolutely can produce more, given their available inputs. Okay, now an absolute advantage has nothing to do with trade. Okay. It doesn't determine trade. It has nothing to do with it. To determine if two countries should trade, we're going to be using the comparative advantage. And here, what we're going to learn to do is to compare, okay, opportunity costs of each product to determine if the two should trade. This one has to do with trade, okay? So that's just kind of a little bit about what the difference between these two are going to be. So, all right, let's see if I can do this. All right, so we're going to determine whether a producer has an absolute and a comparative and take a look at how we do this. And again, we're going to use two separate objectives here to accomplish this, 2 lectures really. So let's start with the first one. Now, this is the same problem that we worked in Chapter 2, but now we're saying that this is the United States. So the United States has 50,000 labor hours available. To produce 1 computer takes 100 hours. To produce 1 ton of wheat takes 10 hours. So remember our steps in computing a production possibilities frontier. So the first step is we use the all and nothing approach. So we're going to say that we're just going to produce computers. And to produce computers, we take 50,000 labor hours, divide that by the number of hours it takes to produce a computer, and we end up with 500 computers and no wheat. Okay? Then we're going to imagine that we just produce wheat. We do the same process. We take the 50,000 labor hours, divide that by the 10 hours it takes to produce wheat, and we get 5,000 tons of wheat and no computers. Okay, now we have endpoints. And so we're going to graph it if needed. And okay, so we can graph the US production possibilities frontier. And there's our plot of 500 down here. So 500 and 0. And here is our plot up here of 5,000. And notice that wheat is on the y-axis. Why? Because when we just did the calculations in the previous slide, wheat was the largest number. Okay, now we can connect those two, and that becomes our production possibilities frontier of wheat and computers. Okay, we now can calculate the slope, right? So we have said that we have 5,000 tons of wheat, and we have 500 computers, again from the previous slide. If we want to, and I think it's the easiest way to do this right here, is to set them over each other. We can go ahead and cancel our zeros, and we end up with 50 wheat to 5 computers. which is 10 wheat to 1 computers. Remember, down here, you have to get a 1 in the numerator, the denominator. I have a 1, so I'm going to go ahead and represent the opportunity cost. So the opportunity cost of 1 computer is 10 wheat. What does that mean? Every time I produce 1 computer, I give up 10 wheat. And the opportunity cost of 1 wheat is, take the reciprocal of this number right here, and we're going to say 1/10 of a computer. Okay, so now after I calculated the slope, I can put my little econ hat on, and I have that information, and I know that the opportunity cost for the US of 1 computer is 10 wheat, and the opportunity cost of 1 wheat is 1/10 of a computer. So that's just from the previous lecture, chapter 2, where we went through how to calculate the opportunity cost using the slope. Okay, so determine how much of each product to produce. If the US divides its labor force, how many computers and how much wheat can it produce? So essentially, we're ignoring anything else here, and we're just saying by itself, the US alone, it could, it's going to use 25,000 labor hours to produce wheat, and it's going to use 25,000, I'm sorry, 25,000, that's right, labor hours to produce computers. So you could go ahead if you wanted to and say, hey, I remember from the previous slide, to produce wheat takes 10. So that means I can produce 2,500 wheat. And it takes 100 hours to produce computers. So 250 computers. Notice that abides by the 1-to-10 ratio, because we essentially have highest common multiple that goes into 250, and 2,500 evenly is 250. So we end up with a 1-to-10 ratio. Okay, so looking at this, we could also say, here's our y-axis, 5,000. Half of 5,000 is 2,500. So I'm going to go ahead and put 2,500 here. And half of 500 is 250. And those two are going to meet right about here on the production possibilities frontier. Again, notice the ratio. It's a 1-to-10 ratio, computers to wheat. Oh, wow, I did that pretty well. Okay, at this point, what I want to do is for you to try a problem. And what I'd like you to do is pause and then go ahead and follow along with me. And here's your problem. Remember, use the all or nothing approach, graph it if necessary, calculate the slope, and determine the opportunity cost of one good in terms of the other. So here's your problem. Use the following information. Draw Japan's production possibilities frontier. They have 30,000 labor hours. Okay, so now we're in a different country. To produce 1 computer takes 125 hours of labor. To produce 1 ton of wheat takes 25 hours of labor. And we want you to go ahead and graph that and tell me what is the opportunity cost in Japan for 1 computer in terms of wheat, and what is the opportunity cost of 1 wheat in terms of computers. So go ahead and pause at this point, work it out, and then I'm going to go ahead and show you how you would do this. Okay, so use the all or nothing approach. So the first thing we're going to do, we're going to imagine we're just producing computers, and we have 30,000 labor hours. To produce 1 computer takes 125 hours. So if I divide that, I've got to get my handy dandy calculator here. Divided by 125. How about 240? So we end up with 240 computers and no wheat. Just produce wheat. We take our 30,000 labor hours, Divide that by 25, and we end up with, I think it's 1,200, but I want to double check. 30,000 divided by 25. Yep. We end up with 1,200 wheat to no computers. Okay. All right, step 2, we're going to graph it. So we're going to go ahead and draw a graph here. And we know, because here's our information from the previous slide. Let's see, I'll write it down here. We know that one computer takes 125 hours, and we can produce 240 computers and no wheat from the previous slide. One wheat takes 25 hours, and we can produce no computers and 1,200 wheat. So these are the points here that we want to put onto the graph. So let me see, did I put it right now? Of course not. Okay, so we're going to go ahead. Which one goes on the y-axis? Obviously wheat, because it's the highest number. So wheat, we're going to say 1,200 tons of wheat. And we have 240 computers. So computers are going to go on the X. And we're going to go ahead and draw our line. Now we could use, I think that's my next step. There we are. 240 or 1,200. And we're going to go ahead and put those two together. Now we still haven't answered what is the opportunity cost of one good in terms of the other, and that's what I want to do right now. And so again, this is at 1,200, and this is at 240. So if we look at this, we can say, okay, this is 0 and 1,200. This is 240 and 0. What's what? X's are computers. Y's are wheat. So I can go ahead if I want to at this point and use the slope formula of y2 minus y1 over x2 minus x1. Remember that wheat are y's and computers are x's. So I'm going to go ahead and put the ones down here, the twos up here. Again, doesn't really matter which one you do. So y2, I put W, silly me. Let's see. Let me just erase that real quick. Not W's, how about Y's? Okay. Okay. All right, so how about Y's? There we go. That makes a little more sense. Sorry, brain moves faster sometimes than the hand and the mouth. Okay, so 1,200 minus 0, again, wheat, over 0 minus 240 computers. So 1,200 wheat to 240 computers. So that ends up being highest common multiple is 240, goes into both. So that ends up being, I believe, 5 wheat to 1 computer, but let me double check. 1,200 divided by 240, sure enough. Okay, so 5 wheat to 1 computer. Now we can go ahead and be the economist, and the opportunity cost in this country, Japan, of 1 computer is 5 wheat. The opportunity cost of 1 wheat is 1/5 of a computer. So now we have our answer that we're looking for. And again, if you could have seen it in this step right here or just wanted to put them over each other, that's perfectly fine as well. Okay. All right, so we already calculated the slope. I did that on the previous one, but we ended up with that the opportunity cost of 1 computer is 5 wheat. The opportunity cost of 1 wheat is 1/5 of a computer. Okay, again, is there a quicker way? Yes, you could have just simply went with the all and nothing approach as we did You have to do that part, and I'll show you why in just a second. So if you took 30,000 divided by 125 for computers, you would have ended up with 240 computers. For wheat, again, you can take the 30,000, divide it by 25, you would have ended up with 1,200 wheat, and you could have just done 240 computers over 1,200 wheat to get the 1 computer to 5 wheat ratio. Now, what you have to do always is that first step. You have to do the all and nothing, because if we wouldn't have done the all and nothing and we would have just went with the information of labor hours, let me show you. So don't do this, it's bad. 125 computers to 25 wheat. Here we would have said, okay, that's 25 being the highest common multiple that goes into both. I'm having a bit of a brain issue here. Okay, so you would have ended up with 5 computers to 1 wheat, and that's exactly the opposite of what the correct answer is. So you don't want to do that, okay? You always have to do the all and nothing approach, even if you're using shortcuts. Okay. Now let's say that suppose Japan uses half of its labor to produce both goods. So again, at this point, we're saying that Japan and the US don't know that each other exist, or they're currently not trading with each other. And so again, if Japan uses half of its labor, then it's going to produce at 600, because 1,200, half of that is 600. 240, half of that is 120. I'll just put it right about there. And notice the 1-to-5 ratio. So that's cool. And we'd be right about here. Okay. Now, at this point, we want to know, because where we're going to go is we're going to then have these two trade based upon the comparative advantage. So we've just calculated the opportunity cost for the US. We've calculated the opportunity cost for Japan. And in the second part, we're going to ask ourselves, should these two countries trade? If so, who should produce what? And then what's a fair price for one good in terms of the other? So we want to get a perspective of what's going on currently. And so this is without trade, okay? One does not know that the other exists. So really important without trade here. And if we look at this without trade, what is our, excuse me, our world consumption? So I like to look at it like this. So the US currently can produce using half of its labor force. So we're going to go ahead with that assumption. Half of labor force is doing each good. Okay, split between computers and wheat, because that's where we left off with each of them, right? So the US right now, splitting its labor force and not trading with Japan, is doing 250 computers and 2,500 wheat, right? And Japan, splitting its labor force, is doing 120 computers and 600 tons of wheat. So to get the total, we're just going to add the two. And I like to think about this as like the world output. And again, the two do not know each other exists. So if you were the ruler of the world, you're just counting up how many each are, how many of each product each country is producing. So if we add the 250 and 120, we get 370. Okay. If we add the 2,500 and 600, we get 3,100. Now, this idea of world output is going to be a barometer, if you will. It's going to be what we measure against to determine if trade makes the countries better off, because we kind of take that world production look at it. So any numbers that we get in part 2 and we assume that they specialize or what have you, they need to be larger than both of these numbers. Larger. And that's why that's what we're going to be using is this 370 and 3100. So we're going to revisit that in part 2. Okay, that's the end of this particular scenario. So it was just kind of a recap on how to calculate the opportunity cost. If you're still having trouble with that, go back and watch chapter 2 and make sure that you understand how to calculate that opportunity cost. Okay, and if you have any questions, please don't hesitate to contact me. Thank you.